So here's a quick video about questions 4 and 5 on the test. So the goal here is to, given a flowchart, you're trying to convert this to a piece of code, and then let's see how we can do that. So the first thing you want to do is we have an input coming in, which is indicated here. It's the input to the function, and then we have initialized two things. The product is equal to 1, so we write product equals 1, and then we initialize the index I to 0. Now if you look at the condition, the loop condition that's testing whether product is less than I, which is really what we're expecting you to write here. Product is less than n. And then if product is less than n, then we have the loop body, which is with these two statements, product equals product times I. So we're going to write product equals product times I. And then we increment the I by 1, I equals I plus 1. And at the end, we're going to return the product. So return the product. Most of you got this one right. I think it's a very straightforward translation from a flowchart into a piece of code. Now, the second part of this question is kind of where something seems to be going wrong here in terms of if you start with I equals 0, the actual value is going to be always 0, because you're always going to be, your product is going to be 0 in the first iteration, and then it's going to remain 0. And then really there are two answers to this. One is that if you didn't think about that, then if you thought about that, you would have said, okay, it is 0, so that's good, we counted that as correct. If you didn't think about that, the correct implementation would have initialized the I to 1, and if it did that, then what it does is to find the factorial, not necessarily the factorial of n, the factorial which is less than the number given. Like for example, what is the closest factorial to n? Say for instance you had 25 as n, then we would find 24, which is the 4 factorial. So what it does is to find the factorial that is closest to the given number, but it is less than the given number. In the second part here, so what we are trying to say is that what will be printed if x equals 21. So suppose you start with x equals 21, and then what happens is if x equals 21, then you will say, okay, well, if you take x mod 5, so you take 21 mod 5, that would give you 1. Or you divide 21 by 5, which will give you a remainder of 1. So what will be printed if x equals 21 would be the value false, because if x mod 5 is 1, then you would print false. The next question is, how do we get this to print the answer yes? So first of all, to print the answer yes, it cannot be any multiple of 5 plus 1, because if it is, then it's going to go into this part and you're done because you're returning. So it cannot be any multiple of 5 plus 1, like 21 or 27, 26 or 31 or something like that. So it has to be something between 3 and -4, but 3 cannot be included and -4 cannot be included. So you can pretty much take anything from 4, which is the positive 4. So we can take anything that's greater than or equal to 4, or anything that is less than or equal to -3. Okay, and so but if you take something greater than or equal to 4, it cannot be a multiple of 5 plus 1, otherwise it would have printed false here. So you can give a number like, well, let's say 5. But if you give a number like 6, that would be wrong. Okay, give a value of x that will print no. So to print no, you must have not this. So that means, say, let's take a look at the x greater than 3. So here's 3 and x greater than 3. So this side here, less than -4, this side here. And so we are trying to determine something in between for the else part. So if x equals 0, then print no. Obviously 0 would be the number to use there because it is between these two numbers. And otherwise print true. So you got to find something between these two numbers that is not 0. So let's say something like 1 would do it. So there are multiple answers to that question, obviously, and any correct answer would have gotten credit. The next part is the recursion, where you are given product helper function, and the product starts with n. So if n is equal to 4, it's going to call the product helper for 1. So that means n is 4 and the subproduct is 1. So what happens next is that because n equals 4, it's not going to go into this. It's going to go into this one and make another call to the product helper. So in that case, it's going to go to n minus 1. So since n is 3 or 4, you will get 3. So you'll get 3, but then you multiply the subproduct by the n, which was 4. So n minus 1 is 3, and you get 3, 4. So the next one, you can imagine what happens. It's going to be product helper here, and then you decrement the n by 1, which should give you 2, and then multiply the 4 by 3, which should give you 12. And the next one would be product helper decrement n by 1 and multiply this one by 2, so that would give you 24. So if n equals 1, you're going to return the subproduct. So at this point, you're returning 24. So as you can see, this is actually another way to find the n factorial. Because n equals 4, the n factorial is going to be 24. Now this part, you're asked to write a search algorithm by your company, and then the idea would be that, so in this problem you're trying to search an element from the back, so the idea would be to come up with a recursive algorithm to do it. And so we have the list that goes from 0 to n minus 1, where n is the length of the list. And so the idea is to look here first, and if you don't find it, then look in the first part of the array. So the base case would be that if the list is null, that means you kept looking and the list became null, and you will return false. That means you did not find the element. Now on the other hand, if you look at the list of n minus, if you look at the element list of n minus 1 is equal to x. Now obviously I have to assume that n is initialized to list dot length. So n is initialized to list dot length. So if you look at the list of n minus 1 is equal to x, then return true. That means you found the list. Otherwise, you want to search from the back. You want to just search in this part of the array. That would go from 0 to n minus 2. So you search the list, the sublist, which goes from 0 to n minus 2, which is this element here. So you have one less element in this subarray than the original one. So that's all you got to do. Now, I was told that there are some subtle things that are associated with Ruby that may make this code not work if you actually type it in. But let's not worry too much about that, and let's just try to understand the idea here. So this is the sort of end of question number 5.